Okay, so what do you notice about the 4 plots? What do you notice?
They all follow a pattern.
Okay, they all follow a pattern. Okay.
So peak is in the middle.
The what?
So it's the peak.
The peak is in the middle for the first one. Dude, straight up struggling today. Okay, peak is in the middle for the first one. There's a pattern. Peak in the middle. What else? What do you wonder? Are there any labels on these graphs? Do we even know what we're talking about? So I wonder what we're talking about, right? Okay, cool. So today we're going to use shape to describe data. Some of this is going to be kind of a little bit of a review. Don't tune me out because there is a little bit of new stuff. Based on the images below, what do you think symmetric means? So looking at these pictures, what do you think symmetric means? They're same on the both sides. Same on both sides. Okay. Like I could draw a line down the middle and it's the same roughly on both sides, right? Okay. All right. What do you think? I'm sorry, what is the mean and the median of the symmetric data? This is the important part. So with symmetric, your mean is going to equal your median. I would write that down. Your mean is going to equal your median. Okay. All right. Based on the images below, what do you think uniform means? Paper. What do you think uniform means?
Same.
The same. So same all the way across, right? Same across. Like literally you can draw a straight line and it is the exact same all the way across, right? Questions on that? Okay. What is the mean of uniform data? Again, this is something that you're going to want to write down. The mean is equal to the median. The mean is equal to the median. Okay. Okay. Based on the images below, what do you think bell shape means? Bell shape. It's shaped like a bell. The peak is in the middle. So peak is in the middle. And it's shaped like a bell. Cool. These are not trick questions. You just have to know these different words. Okay. The median and the mean are also equal for a bell-shaped curve. The mean is equal to the median on the bell-shaped curve. Okay. What do you think bimodal stands or means? What do you think bimodal means? Looking at the pictures on the board. Two peak. Okay. The word bi means two. Okay, so we've got two little like peaks. Okay. Now, here's the deal. If it is symmetrical and it's bimodal, then our mean is going to equal the median. So if it is symmetric, bimodal, then mean is going to equal the median. If it is got two peaks, but it is not symmetric. So looking at this data, a lot of our data is down here, right? So that means that the median is lower than the mean. Okay, now that's not going to be necessarily the case for every single one of these, but majority of the data is down at the bottom, so the median is going to be lower. Okay, what do you think the word skewed means?
So it's one side.
Say it again. Peak is on one side. Okay. Okay. So most of the data is pushed to one side or the other. Plus. All right, here's the important part. If you haven't been paying attention thus far, now's the time. Skewed left. All the pictures in gold or orange or yellow, whatever you want to call that color, they're all skewed left. What does that mean?
Push to the left.
They're pushed to the
side
left.
is pushed.
The left side is pushing to the right. Okay, so majority of your data is on the right, but you have a tail on the left. And that's why it's skewed left, kind of like pushed from that left-hand side.
So you say the opposite words.
Yep. So you can think of it two ways. You can think opposite of the majority of the data, or you can look at the tail. Okay, so many times what people do is they take their pencil and they draw the graph like shape. And you see how there's like a little tail out here? That's why it's skewed left. Now, again, the important part. If it is skewed left, then that means that the mean is lower than the median. The mean is lower than the median.
How do you know? How do you know when where? Like what number?
We're gonna talk about that in a little bit.
Isn't it like all the numbers like?
So add up all the numbers, divide by how many numbers there are.
But like all these symmetrical ones, it's like right in the middle.
So with skewed right, we've got a tail going to the right. Okay, so tail is going to the right. Okay. Now, again, here's another thing. The mean, I hope I said that right on the last one. Median is lower than the mean. The last one I put mean is lower than the median, right? Okay, cool. The mean is lower than the median. I think I said that on that one. Okay, so on this one, the median is lower than the mean. Kind of want to think of it this way. Majority of your data is over here, so the median is going to lie in there. Okay, so if you're ever like, I don't know which one it is, where's your majority of the data? Your median would be near that. Okay. All right, so take a moment, select all the terms that describe this shape of the histogram. Take a moment, try that. All right, so what'd you come up with for this? What describes the shape? Symmetric and bell shaped. Symmetric and bell shaped. Okay, go ahead and take a moment. On this one, you're going to answer 1, 2, and 3 are the same problem, and then 4. Okay, so you're just going to describe these. Okay, take a moment, try. On the first one, what should you have gotten? Symmetric. Second one, what should you have gotten? Skewed right. Okay, and then the last one, uniform. Also symmetric. Uniform and also symmetric. Yeah. Everybody good on this? This should be the easy stuff. There's always one question on your EOC about the shape of the graph. Okay, cool. All right, go ahead and take a look. Yeah, it's not bad. Okay, so while you're finding that, how many of y'all have played a sport? And how many of y'all have played a sport? Okay, one person, 2 people in this room? I don't believe you. Okay, so when you play a sport and okay, when you play a sport and then you have that like one person on your team that like does pretty well the one day, and then the next day they absolutely suck at whatever they're doing. And like you can never really like trust them, right? They have a lot of variability. Okay. Now, if you have a consistent player that does the same thing every single day and you know what to expect of them, that has less variability, right? Yes, no, maybe. Okay. So variability is talking about the difference from their highs and lows. Okay. It also talks about how spread out something is. So variability is talking about the spread of something and the highs and lows. So I want you to look at these three graphs and tell me which one is the least variable to the most variable. They all have the same range. So in order to find range, we're going to take our high and subtract our low, which is 8. We're going to take our high and subtract our low, which is 8. And high and low, which is 8. Okay. Now, looking at these, most of our data on this one is in here, right? Most of our data on this one is in here. And then most of our data in this one is here and here. So which one is most spread out? I think it's C as well. Okay. Between these two, which is the least spread out? Okay. Do you agree? B, why?
Because it has like the most.
Okay. These are kind of very similar, and you could probably argue for one or the other. I went with B as being my least, and then A, and then C. Okay. Now, that being said, though, these could be flopped. Okay. We didn't calculate the standard deviation, which is what we're going to talk about today. So, interpreting standard deviation as a measure of variability. In this unit, we're going to look at statistical reasoning framework where we ask, collect, analyze, and interpret data. If you're trying to be a statistician, or if you're trying to go into business, or if you're trying to look at, go into like sports analyzing, this is going to be the unit for you. When analyzing data distributions, we can calculate and interpret measures of center and measure of spread. In your math journey, you've learned about these measures. So just a recap, mean is also known as the average, and it's the sum divided by the number of numbers. Okay. Median is the middle number. And mode is most often. Range, thank you, is going to be a high number minus the low number. Okay. Interquartile range, we're going to talk a little later, but that's going to be Q3 minus Q1. And then mean absolute deviation, we're going to talk about tomorrow, so don't even worry about that one. Okay. So again, we're going to study standard deviation, which is known as the measure of variability. So go ahead and flip the page. Okay. A measure of the amount of variation of a set of data values. A low standard deviation indicates that the values tend to be close to the mean of the data. Okay. So for instance, student size of 6 students. We've got 5, 6, 6, 6.5, 7, 7. The mean, also known as X bar, is 6.25. The standard deviation is going to be 0.7. Notice how it's really low because these numbers aren't spread out. Okay. Over. So, okay. Calculate the mean and standard deviation of the data set. All right. If you have not been paying attention, now's the time to pay attention. So 10, 11th grade girls were asked to estimate how many hours a week they spend talking on the phone. The dot plot represents the number of hours of phone usage per week. Okay, first things first. When you get a dot plot, you need to make the list of numbers out. So for instance, there's 1 dot on 8, so we're going to have 1 8. And then we're going to have 1 dot on 9, 2 dots on 10, 2 dots on 11, 3 dots on 12, and 1 dot on 14. First of all, why is there a girl spending 14 hours on the phone a week. Nope, just me. Okay, thanks, guys. So, with that being said, now what you're going to do is you're going to find the mean. Okay, the mean is found by adding up all of those numbers and then dividing by how many numbers there are, which is 10. Okay, so take a second, add up all those numbers and tell me what you get. You're adding all of those numbers. Add up all those numbers and then divide by 10. It should be 10.9. Not sorry. So it should be 109 divided by 10. Okay, so add them all up and then divide by 10. What? I got a Sharpie. Yay. Good job. I mean, this pen is kind of sucky. 10.9. Okay. It should be 10.9. All right. So you should have gotten 109 divided by 10, which is going to give me 10.9. How many numbers there are? Yeah. Okay, you ready for the crazy part? This is where it gets crazy. So you're going to write this formula down. So for standard deviation, we represent it by using the symbol sigma. It's like an O with a little curly thing. Okay. Equals. All right, don't freak out. It'll be fine. Okay. The square root of the sum of x minus x bar squared divided by the numbers. Yep, that's it. Yeah. Okay, so actually these are Greek letters. So sigma represents standard deviation. This big sigma represents sum. Okay, x bar represents mean, and n represents the number of numbers. Yeah. But wait for it, because we gotta actually calculate all this junk. Okay, I would make sure that you have some space on there when you do this. So the first thing that you're gonna do when you're finding the standard deviation by hand is you're gonna make like kind of like a little table. Okay, so you're gonna make a table, you're gonna say X, and you're gonna list out all these numbers in that table. Okay, then what you're going to do is you're going to take all those numbers and subtract the mean. Okay, so you're gonna take each one of those numbers and subtract the mean. So you're gonna do 8 minus 0.9. I'm sorry, 10.9. 9 minus 10.9. 10 minus 10.9. Okay, and you're gonna fill in this column. So take a moment, go ahead and do that. Yeah, love it.
What's that line above?
X bar, but there's actually like a name for it. I'll have to look it up.
I'll show you. 8 minus 10.9. It's negative 2.9. Basically, 9 minus 10.7. Yes, it's negative 1. It should go, it just, and then 10 would be 0.9, negative 0.9. And then the 11 would be negative 0.9. Negative 0.1.
Okay, so now that you've done all of that, what you're going to do now is take all of those numbers and then square them. Oh, yeah. So x minus x bar, and we're going to square it. Okay, you should not get negative numbers when you square something. Okay, so keep that in mind when you're doing this. Okay? Take a moment. I know. Negative 2.9. 8 minus 10.9. Flip 2 pages, maybe 3. Yeah, that one. Flip 2 pages, 3 pages, and it should be out there. 0.1. So once you get here and you have filled in all that junk, you're gonna take all those numbers that are in the last column and you're gonna add them up. So add them all together. Yep. I don't know. I'll have to look it up. What's up? Love to see it. Love it. Okay. 12, 1.1, and 1.2. I got 26.9. Yeah. 26.8. I think I'm missing a 0.1 or 0.01. Okay, so when you add those together, you should get something like 26.9. Now we're still not done. Yeah, we've got to divide it by the number of numbers. So how many numbers did we have? 10, right? Okay, so 26.9 divided by 10, and we're still not done. We've still got to take the square root of that guy. Yeah. Yes. So it's 1.64. Okay. Now that you've done that one time for 10 numbers, which most of your data points, by the way, like most of your sample collections are between 20 to 1,000 samples. Imagine doing this for 1,000 samples. You'd be here forever, right? I'm going to show you the shortcut way to do it. Take out Desmos. Take out Desmos. We love Desmos. It's our favorite. Yep, Desmos graphing calculator. Once you get here, what you're going to do is you're going to type G equals, and then you're going to use brackets, and you're going to list out all those numbers, okay? You're going to list out all those numbers. You're going to say G equals, and then list out all the numbers. Now, once you've listed out all those numbers, here is the magic code. You type STEEVP and then put G in there. And look what pops up. Your standard deviation. I didn't have to calculate nothing. It does it for me. This is great. If you wanted to find mean, you would type mean, parentheses, G. Look at that, 10.9. If, let's say that they don't give you the scatter plot, then you type scatter plot, G. Oh, it might be abbreviated. Hold on. I think I wrote it on your thing. I never use this one. Dot plot. That's what it is. Boom. Look at that. And it creates it for you. Ooh. Yep. If you forget, Like if you're like, I don't even remember how to do the standard deviation, like I don't know what the code is, you can go to this little keypad on the bottom left-hand corner of your screen, and then you can scroll down, click on functions, and then scroll down to where it says dot plot, and then all you would do is type G. You could scroll down to where it says, should say standard deviation.
Wait, how do you, use standard? Can you like scroll up real quick?
So standard deviation is STDEVP. There is a difference between this standard deviation on the left and this standard deviation in the middle. The difference is when you get to AP stat, STDEVP is a population. STDEV is talking about a sample. Does that make sense? The population would be the entire population of the school. A sample would be this classroom. Yeah? Okay. So with that being said, I want you to try this next one. So looking at this one, I want you to find the mean and the standard deviation. Yes, you can use Desmos. Okay, go ahead and try that now. So you should have gotten a standard deviation of 3.77 and a mean of 4.3. Okay, so down here at the bottom, mean of 4.3 and a standard deviation of 3.7. So which one had a greater mean? The girls. Okay. What about the greater standard deviation? Okay. So on here, we see that the standard deviation is low and it's all kind of grouped together. Standard deviation is higher, so it's kind of more spread out. Okay. Really quick, we are going to kind of pause, review for our mastery check, take our mastery check, and then I'm going to give you an assignment to gather data. Okay. Actually, we might put it on that board over there. We might do that really quick. Okay, so over on that board, you're going to